Okay, hi again, everybody. I want to show you this thing that's called a line of best fit. And just to give you a quick definition of it before we get going, or actually, let me back up. Basically, what we're going to do on this example problem is we're going to show you how to take all of these points right here and create a linear equation that represents them. So that's our ultimate goal. And to do that, as I mentioned, we have to do what's called create a line of best fit. So let's back up here and let's talk about what these things are. And so a line of best fit, it's a way to show a relationship between a scatter plot and an equation. So a way to show a relationship between a scatter plot and an equation. Okay. Remember what a scatter plot is. It's just when you plot a bunch of points. Well, the line of best fit is the line that represents those points. Okay? Now, it won't hit every point every time. But what the line of best fit does, okay, what the line of best fit does, it lies as close as possible to all the points. So the line of best fit lies as close as possible to the points. Like I said, it won't touch every single one of them. It will come really close to most of them, but most of the time it won't hit any of them. Okay. I also want to mention this other and get this other key term in there. This thing called a correlation coefficient. And a correlation coefficient is it's a number. Okay. It's going to be between -1 and 1. Okay. And that number measures the quality of the fit. Okay, measures the quality of the fit. A number that is close to 1 or -1 is considered a good fit. Okay? So you've done scatter plots before, you've seen them in the past, and so what we're going to do now is create this line of best fit. Okay? So let's go ahead and go to the example. Right? Now, essentially what I'll be doing is creating this line that represents all of this data. The process to do that is right here with a couple of edits that we'll mention as we go. Okay? So, first edit that I want to do is on your calculator, if you haven't done this yet, I'm going to have everyone do it. You have to do what's called turning on some diagnostics. When you turn on diagnostics, all this stuff in this window actually shows up. So how do we turn on diagnostics? Well, it's really simple. You got to hit your second button and then go down here to the 0 where it says catalog. And you got to scroll all the way down to the D's. The D, huh. Alright, almost there. And you want to find diagnostics on. Click that, hit enter, and you should only have to do it once, so it should be done from now on. Okay? Alright, once you have your diagnostics turned on, you're good to go. How about I clear it? There we go. Alright, so now we can start this process. So the first step we have to do is we have to take our two pieces of data and we have to enter them into two lists. So the menus for that. Real simple. See this key that says stat? So we hit the stat key, and then we choose the edit option. So the edit menu, the edit option. So I'm going to write that down. So stat, and then edit. And I'll write them in all caps because you can see the menus are in all caps. The stat menu, and then the edit menu. And then I choose edit. This one right here, so I can just type 1. Okay, and you're given 2 lists, L1, L2. If you have any information in these lists, what I want you to do is I want you to hit the clear button. Do not hit the delete button. Hit the clear button and it'll get rid of all of them. Okay? Alright, so this is a pretty simple process. We take our data, and in L1, I'm going to put all of these numbers, and then I'm going to go over to L2 and I'll put all those numbers. So this might take a minute. So 40, 45, 32, 50, 37, 41, 30, 34, 47, and 45. All right, good. Go over to L2. I just hit my left arrow key, right arrow key. So we got 170, 183, 151, 195, 162, 174, 141, 151, 185, and 182. Now, make sure before you move it forward that you have the same number of items in L1 as you do in L2. Okay? That's the hard part, folks. All right, so let's go over to step 2. Step 2, use linear regression feature. So how do I find the linear regression feature? Stat, hit the stat button once again. So it's stat. And then you go over to the calc menu, which is right here. So I hit my right arrow key, calc, and you want linear regression. So calc, write that down, and then down there we want linear regression. I'm just going to point up to there. Okay? So you choose option 4, linear regression. So I just type in 4, I hit enter. Voila, there's my equation. Now, what does all of this mean right here? See how we have y equals ax plus b? We have a with a value of 2.6035, and we got b with 64.99. The a is my slope, okay, in this equation, y equals ax plus b. The b is my y-intercept. Now, see this number down here, the r? The r is what we call a correlation coefficient. If that number is really, really close to 1, which it is, that means that this is a good representation of, of the data. Okay? So what I want to do is I wanted to go ahead and copy this equation down. And let's copy it down over here on the example. So I'm going to go out a couple more decimal places. I don't like rounding to 2.6 like the book did there. So let's go this. Let's go y equals 2.6. Let's go 0.4. Let's go 3 decimal places. X, because my a value right there. And then I got 64.997. Okay, what we just did in this problem here is we just found the equation of the line of best fit. Okay? All right, so if I look at this entire equation, so these are the firmer links, which I believe is what, the upper leg. These are the height of the people. So does this data show a linear relationship? I would say yes, there is a linear relationship. Okay, so yeah, I'd say there's a linear relationship. Why? Because I could get a linear equation with a high correlation coefficient. We found the line of best fit, which is right there. Now, how are we going to use it to estimate the height of a person whose femur is 35 centimeters long? And that's where I'm going to deviate from this book right here. So I'm going to cross this out. I'm going to cross this out. What I want you to do in step 3, I want you to put the equation in the y equals of your calculator. Whoops, that's step 3. Woo, still struggling. And step 4, table feature. Table feature of x equals 35. All right, so let's do that. So my equation up here, I'm going to go 2.604 x plus 64.997 second graph for my table, and I'm going to scroll all the way down using the arrow key to 35. All right, so there's x equals 35, which is, if we look here, that's the length of the femur, which we talked about being x. So the height of the person would be my y, so I got, what, 156.137. So the height at, we'll say just x equals 35. Is, we can probably round that out. See those little squiggly lines? That means approximately 156 centimeters. So what's that mean? A person who has a femur length of 35 centimeters, they're about 156 centimeters tall. Okay. Now, if you look at our graph right here, so you can see 32, we're at 151, so that's pretty close to that. That should make sense then that 35 would be 156. 37 is kind of on the other side of that, 162. 34, really close, 151. So you can see that data is pretty reasonable. Okay. All right, so in class we'll practice line of best fits and give you a chance to just practice one so live. So if you have any questions, we can answer those questions. But hopefully that makes sense, and go from there. All right, have a good weekend.